Good afternoon, everybody. I mean, we're all kind of on the same theme, and to me, this has kind of been an item that we should have been addressing a long time ago. There's one thing about a level slab on grade that you have a uniform thickness, uniform elevation on top and bottom. But then when you get into slope paving and warp paving, it's a whole different animal that we haven't been really understanding what we have actually been placing out there. And I think some of the topics have been brought up that when a building, we've sold a building, everybody's good. And then when somebody else buys it, then they say they want to come out in core, then they say it doesn't meet ACI standards. There's a lot of money lost. Perfectly good concrete being replaced out there that could have lasted 30, 40, 50 years, but the rules don't match with what we're doing out there. So regular HEB, a shopping center, you got paving, 5-inch paving, maybe 7-inch around the back. You know, how do you get the average thickness? So the old way kind of is, you know, you go out, you can figure out a 20-foot grid. You can go and say, I'm going to map out a 20-foot grid. I'm going to check the tolerances on those 20-foot grid. But to me, that's predictable. If you can make the answer work out if you know where you're measuring, right? That's not good for the industry, right? So you don't want to do that. You want it to be random. Eldon invented this great random generator. I just thought it was a brilliant idea, and we took that and we used that, and then we've improved it a little bit along the way. But as Eldon was talking about, it's just randomly putting those points in the area that you're pouring. I think that's really important because everybody's doing it differently. You got a lot of different contractors out there. You got some small contractors, got some large and medium contractors, all doing it different ways with different technology. I think we have to understand what kind of technology is being used. This is where it happened. Where's the location? What kind of subgrade? Is it lime stabilized? Is it cement stabilized? Is it aggregate base? All those things matter. How is it being installed? Is it installed by a backhoe, box blade, a dozer, motor grader with 3D capabilities? All those get as you change those operations. Again, every pour is different. This time we've got about a 30,000 square foot pour. We've outlined it there. If we had a couple different shapes, we have part of the random calculator. We can do a couple different shapes, but you just need to isolate the area that you're working with and define it. Checking grades, still string line. How long are you spanning that with a string line? How taut is that? Motor grader without 3D capabilities, motor graders with 3D capabilities. You can have a lot of different things that I've already mentioned on how to grade your subgrade. So here's the calculator. We enhanced it just a little bit, and I'll show you that up in the section where it says section 1 and section 2. So we added a section. So if you had a couple odd sections, even an L type, you can say one section and then do the other and have your random numbers associated with that. Got everything in your CAD. You've logged in all your points for your curbs and your islands and things like that in your parking structure. So you have everything defined, what's paving and what's not paving. So then up there at the top of that section 1, now we're saying it's the 300 by 100 defined area. 30,000 square foot. When you plug that in, it automatically is going to create one random point per every 1,000 square foot. So it keeps it consistent. It's not just whether I want to do 20 points or 50 points. It's going to generate 1 point per every 1,000 square feet. So right here down at the lower live set, we're talking about the base data. That's the section we're on. We're dealing with the base material right now, and we're talking with the random This will probably still work. Oh. All this random generated. So just like Eldon was saying, from east to west, north to south, it's going to create some points on our sheet in our paving area to locate those random points. So here we go. All these points just random. Here's E3, here's E2, here's E8. These are just randomly in there. So you can't predict where they're going to be. And what I'll be showing you here in a minute, that we have a couple points are actually inside the islands. So we want to still have 30 samples, but if 2 of them are in the islands, it's not in the paving. So you want to randomly get those points back in there and not just put them where you want them to go. So again, that E2 right there outside the area. So we're going to put it back in our calculator, and the new version of this will allow us to do E2 and E30 and put them in as new points. So up on the very top right, it's a new random generator. So we're going to go into sample number 2, which is the east-west is 65 and 89. And we're going to put a 2 in the top up there and generate a new point at 134 and 43. So it automatically, randomly does that. So it's not hand-picked, so you can pick the answer that you want. Same thing with point 30. We just switch that out. We have a new random location. And now we have point 30 and point 2 just randomly put in there. Now we've got 30 points in a 30,000 square foot paving pour that's going to give us samples. So you got your total station, you got your benchmark, your known elevations, total station, and now you're going to go check the subgrade according to that elevation. And as simple as hitting those 30 locations with this instrument, and you're logging in that elevation. So up on the top left, it's the thickness design. So you know it's 5 inches. You've got all your elevations logged in for what your as-built for your base material. Now we're getting ready to move to the paving data. So you move over your tab. And again, there's a lot of different ways to strike off the concrete, right? You got 3D laser screeds right now. You can hand screed it, wet screed it. There's a lot of different ways you can deal with the surface. But again, these are all warped surfaces. And I think that's the difference, that we don't have any real data. And that's what we've been working through 2017 to get some data to know that the paving out there has been performing for 20, 30 years very well. Most of the yield at over millions of square foot of paving is about 2% to 3% over neat on your concrete yield. That's consistent, but you'll see, then you come back, same benchmark, everything stays the same. Now you're checking the surface. Now you're logging in the surface data and the elevations for each one of those 30 spots. So now you got your as-built, you got your top, same 30 spots. And after that's punched in, really the system is going to calculate everything for you. So the average over all 30 of those is 5.23, a little bit less than a quarter inch over the whole entire 30,000 square feet, but only for those 30 samples. These colors, we just did these colors just so when you scan it, you can kind of look at it real quick, and we'll go through it. It's the green is really within a quarter inch of design thickness. So we're looking at that. We've got a fair amount. I don't have the percentage of actually what's in the green right there. So, but you can look at some of these. There's one that is 6.1 inches. That's it, you know, a little over an inch thicker. And you have some at 4.6 inches, and I think 4.48, which is, you know, under a half inch less. And we've spent a lot of times, I mean, this is kind of stuff that we produce every day, and I don't think that the data that we have and the rules in ACI match what we're doing out there, and I think we're a good contractor. And there's others that maybe aren't as sophisticated and stuff, that it could be a lot worse. So that's why we're bringing it up. So again, the orange 1/4 inch to a half inch difference from the design thickness, and then anything in the red, it's more than a half inch. And but you can see the yield is about right where you'd expect it to be. So when we finish it, we would think that we did a good job. But so this is the data. I just wanted to take, Eldon had an awesome idea. We got to go collect the data, because I know I look at paving specifically that we placed 30 years ago, and it's performing very well. And it has this kind of data. If not, it may be even more outside these lines, because the type of equipment we were using back then compared to the type of equipment that we're using today. That's all I have.